Hi, I'm going to be explaining the project that I've done for 1.125, and it's a website that helps to simulate how good ideas spread. So let's say you're in a network. This can be a network of individuals or organizations, and someone has a really good idea. Well, the people who are connected to that person will go, I like that idea, let me adopt that, and then they get the good idea as well. And everyone that they are connected to also can get the good idea, and that's how the good idea spreads across the whole network. But let's look at a case where the person in the middle actually has not a very good idea, and someone on the side has a really good idea. Well, that one who can choose between the both will see, I like the better idea, I'll take that one, and he gets the better idea. But everyone who's connected to the poorer idea can only get the poorer idea. So from this, you can start to get an idea already of how good ideas can spread. One factor is how connected people are. Another factor is whether people will actually change their minds. For example, that guy in the middle can decide to take the better idea that someone else has, and that good idea can then spread to the rest of the network. And lastly, there's also an issue of how well people copy other people's ideas, because you can try to copy something that looks good, but if you don't know how to replicate it, you're not going to have a very good idea in the end. And that also depends on how complex the problem is that you're trying to solve and how well you can copy the idea, the solution for it. So now I'm going to bring you through what the website looks like. When you first come, there's a window welcoming you to the web page. And when you close it, you're already invited to start running the simulation. So here is where you set up the network structure, what kind of network you want your idea to propagate across. And it's based on something called a Watt-Strogatz model, where you have to specify how many nodes you want, how many connections each of those nodes will have, and what is the likelihood that the connections between the nodes will rewire. So you can generate a graph. It'll look something like this right here. And the next thing it asks you to do is define the problem landscape. And here you can say how many dimensions there are to the problem and how interdependent the solutions will be. And I won't go into this, but this is what determines how complex the ideas are that are being transmitted throughout the network. And then you generate a landscape. And you see that now each of the nodes has a different color and size, which corresponds to exactly how valuable the idea is. So this one has a value of 0.55, a tinier one over here has a value of 0.25. And next we're asked to set the adoption quality, and so that is how well you will be able to copy an idea that your neighbor has. So I'm going to say it's just going to have normal copying error, and I set this adoption property. And it then shows me the next thing I can set, which is what parameters I will use for the simulation. So I will just call this, say, sim1, and then I will let it run for 20 time steps, and then I click run simulation. And now it gives me this completed run that I've done right here with all the variables that I've included inside. And when I click play simulation, I now have the controls to walk through my simulation. So this here is the time t equals 0. And if I toggle one step through, I get to t equals 1. We can see the ideas have changed, and t equals 2. And as you can see from the graph, this is where all of the ideas in the network have stabilized already. I can go to the start and click play, and the simulation will run itself. If I want to start another simulation, I just click start another simulation, and I'll be run through the whole process again. Let's call that sim2 for 10 time steps, run a simulation, and you can see now when I play this simulation, I have my second simulation here, and these are the time steps, and I can switch back to my previous simulation and run that one as well. Thank you.